So welcome to Team DataFam Tableau User Group meeting number 7. This TUG is run a little bit differently. We cater for the presenter rather than the audience. So meetings are held when the presenter is available, which is why we're meeting now, because now Colin's available. It's for any presenter that wants to reach a wider audience. So obviously our meetings are live and they're recorded and they're put on YouTube for further consumption later on, obviously. We've got a lot of TC25 presentations coming up, but I think today it's not a TC25 presentation, which is really good. I'll talk about that more on the next slide. But if you want to present at the TUG, please get in touch. Email team.datafam@gmail.com. Today's presentation is driving revenue growth through Python-based predictive models and Tableau. Huge mouthful, but obviously it explains exactly what the session's about. So Colin is going to take us through doing advanced analytics, machine learning, market efficiency. I think he can create some sample data for you as well and actually show you how to do it on your computer. So without further ado, I'll hand it over to you, Colin.
Awesome. And I think feel free to unmute people. I have a 5 or 10 minutes for back and forth kind of conversation. If they want to speak at some point in the next few minutes, they're welcome to.
Sure, I'll do that now. I'll make everyone a presenter so that they can actually unmute yourself and talk if you need to, or if you would like to.
So this is a picture of me. I'm Colin. I work at Living Spaces. It's a furniture retailer. We do mostly in-store, but we do have an online as well in the United States. So a lot of the stuff I go over might sound very similar to Superstore kind of data, and that's by design. And yeah, I just had a few questions. I'll do a full screen here. And I'll have my contact information at the end in case you guys want to screenshot it and reach out to me at some point down the line. So the first question I have, and I'll pause and let people respond, and if not, I'll go ahead and answer for you. But the first one is, what business questions might a web retailer ask? Just to start out with. Feel free to shout out. So my mouse is missing. Oh, here it is. So my response to that would be something along the lines of how much money did we make? Will we make? Right? That's a question that every retailer would like to know. How much did we spend? How much should we spend? Right? What products do people like? What's in style? How long is it going to take for us to ship our products to each customer, et cetera, right? Those are all different business questions that might be asked. And so the next few are questions that I sort of rhetorically ask myself every time I'm given an assignment. So the first one is, what data do we need to predict revenue? So today's session is about predicting revenue. And obviously there's thousands of different variables that could be used to predict revenue. So usually when I start, I know that in my data warehouse or my cloud storage platform or whatever it might be, even my local computer, we have tons and tons of information, tons of data sources. And so it's kind of easy to just throw everything into a table and then pump it through a model and then see what you get, right? Especially with AutoML and different things of that sort. But that's not really practical on the data engineering team, for example, or potentially if you add too many columns, you're going to be using the wrong granularity. A level of detail would be the term that Tableau users often use. And so the question is, what information should we omit, right? And that could be for technical purposes, or it could be for the audience, right? So if if there's p-values or r-squared values and I'm presenting to the CEO, I'm not necessarily going to show that, right? If I'm presenting to my coworker who's a data scientist, I will show that, right? So there's different information that you want to admit. omit, depending on who the audience is. The graduate course I took at USC, University of Southern California, in the US was called strategic ambiguity. So that's where I learned about that. So this one I just discussed. And the last question is, what is the best way to display this data? So I'm going to go over a few of those options. So there's basically a list of options, and this is a screen grab I saw at Tableau conference. I've been twice. I think it was 3 years ago. It was the first one back after COVID. And so basically everything boils down to what do you want to have stand out, right? So in the case, and they're able to see my mouse, right, Chris?
Yes, yeah, we can see your mouse.
Okay, cool. So in the case, you've got 4 leaves here, and so you've got a background, right? So if you want this leaf to stand out, there's a couple things you can do. You can make it red. You can make the background blurry, right? Because otherwise, if there was no background or the leaves were all green, it'd be hard to point out and see what's standing out, right? So besides color, there's a lot of other options here, and these are what I guess the Tableau community refers to as the pre-attentive attributes, right? So if you have 4 bars and 3 of them are the same and one's shorter, obviously the shorter one will stand out, right? If you have a bunch of curved objects and a straight one, the straight one will stand out, right? And so there's different options here. So that's it for the PowerPoint, and I will pause for a few seconds in case anyone wanted to chime in or had questions.
Everyone is marked as a presenter, so you've just got to unmute and you can ask questions. And no one's going to ask questions as well.
Okay, sounds good. So I will come on over to let's do Tableau first. So basically, this is what we're going to dive into, and I'm trying to do about half focusing on front end and half back end. So the front end stuff will be obviously what we see here, and the back end stuff would be done in Python. If you've never used Python, don't worry, it's free, and you can download it on any computer. And then all the scripts are already written, so you can just run them yourself. And there will be a sample script which can be used to produce your own dummy data. This is all dummy data. A random title here. Some information on our retailer, right? So we have visits to our website. Some are on desktop, some are on mobile. We see that the mobile average time on site is longer than desktop. We also see we've got more page views per visit on mobile than desktop. And the bounce rate is basically how many people click off your site like within a second, right? So potentially mobile is a lot of people clicking ads on social media site, and then it's an accidental click, right? These are just some overall stats for the website. Really, what I'd like to go over is this graph right here. And so basically what we see here, and I'm going to open it up, oops, sorry, in a worksheet, is we've got different revenue forecasts, right? And I'm going to show you guys how I created the data to produce this, right? The blue dashed line is actual revenue. The gray bars are what our model predicted. So basically we had 3 different models, and the range went from anywhere from the bottom to the top of the bar, right? This sort of view is something, and obviously we see the model is really good at predicting because all of the dashed lines intersect the gray bars, except for this particular time period, right? So there's a couple of things I can do here. You see that when I hover over it, it shows me all the actual revenues, right? If I'm a little annoyed by that, I can basically I have a few different options, right? I can do the end, I can do line ends, I can do selected, which means I have to actually click, and then it'll show me, and I can unclick, right? In case someone wanted to know the exact value, or I can do all, and it just shows the all, right? If I do highlighted, it just shows me the highlighted. If there's questions later about how did I build anything visually, please let me know. We'll circle back. So this sort of view is something that I would show like an upper manager, a CEO, a CMO, etc. Basically, a huge conclusion that are based on our our variables that we will go over soon. We are able to successfully see the revenue being predicted a majority of the time. I'll show you something really cool, which is using motion graphics. I think would be the name for it. There's a pages area over here. So if you'd like, I can try to do it for you right now. But basically, I can press play and see the line being drawn, right? Or in theory, if you'd want, you'd want the gray bars, right, to be shown permanently, and then the dashed line to be drawn. So I'm not going to build that right now, but you could, in theory, have a presentation where you have all these gray bars, and you show this, and then you bring the audience in, and you show the dashed line being traced and falling as you're speaking. So you have some sort of like movie running while you're talking. That would be an option. Anyway, so there's a couple things you can pick up on. Some of the bars are big, some of the bars are small. And so obviously there's more certainty or less certainty depending on the week or the month, right? So if I go back to the main dashboard and I click here, now we see a pop-up of the actual models behind the scenes, right? So I'm going to make this a little bit bigger. Well, first of all, we've got our 3 models: Ceremax, XGBoost, Random Forest. This is a seasonally adjusted, autoregressive, I forgot, moving average with exogenous variables. So exogenous variables are things like the weather, or something that's not really in your control. That's my understanding of that. And seasonally adjusted would mean that there's seasonality present in the data. Obviously, that visually you can see that occurs because there's a lot of ups and downs, right? Okay. I'm not going to go over what these other models mean, but yeah, if you have questions about that later, we can talk about it. But in the case of a data scientist, they might be interested in saying, well, hold on a second. We've got 3 different models. How good was each one, right? So I can hold control, and this is our actual revenue. This is our random forest. So we can tell, okay, the random forest was a little bit below this week, a little bit above this week, right? It was predicting, 850K, and the actual was 840 or something of that sort, right? We can also see that the Ceremax is chronically under estimating or predicting the revenue. This would be a model that we maybe want to question or adjust, because the correlation looks really strong. It's just a little bit too low, right? And the random forest is somewhere in between. If anyone would like, I can show them how I created the sheet swapper. That's super easy to find online. If you'd There's already tutorials about that. I'm going to go more into the math stuff. What I did down here is basically showed a way that you can put a filter for outliers, right? So let's pretend that we have the number of transactions, the number of visits. So obviously, the more visits we have, the more transactions we have, right? And the transactions divided by visits would be considered transaction rate. And that would be like the best fit line here. But if we want to consider a certain point an outlier, then we can just use a filter like this and it'll adjust, right? If we want to see all the numbers, it would be like this. So that's just a little bonus in case you guys want to use that for your dashboards. I strongly recommend it when you have a scatter plot. The way I defined outlier is pretty simple. I just said that if there's more than 43,000 transactions, to call it an outlier. Otherwise, consider it to be a normal week. Any questions on Tableau before I go into some of the data modeling math stuff?
And yeah, if you want to, Cassie was just, when you said about the sheet swapper, she said, yes, can you show about the sheet swapper?
Oh, sure. Okay. Yeah, definitely. And if there are questions, it's easier if you Chris, let me know what they are. That would be the best way.
Yep,
I can just listen to your voice instead of going back and trying to read everything.
Yep.
So the sheet swapper, and you can download this from my Tableau public, which is, where is it? Well, let's find it. Here's how we find it. We do Colin McDuffie Tableau public. And then you click the second one, and then you click my name, and here we are. Okay, so this is the dashboard, and then you can download it right here. So download. I made it available. Anything you'd like to download. So if you need to review the formulas and all that later that go into the sheet swapper, then definitely you can download it on your own time. And even if you have the free Tableau public, it'll still work. So, but yes, so basically so I have a couple things going on. So I have this parameter called sheet swap, which is not opening. Oh, here it is. Now it opened. So I call it sheet swap. Data type is float. And I just put 1 and a 2. So the two options for my button are hide the models or explore the models. Then I have this field, which is basically there's a thing that will be said during Tableau tutorials, which is anytime you make a parameter, you also have to make a calculated field that brings the parameter by the dashboard. So in this case, I'm just bringing that field in. So then I have a filter, and I use a custom value list, and I just push 2 because I only want to include the value of 2. Right. Their dashboard or my other worksheet, which is this, where'd it go? Which is this one. I did the opposite. Let me here. Oops, opening. Oh, it's because it's this. Oops, sorry. Oops, sorry. So I set it equal to 1. So use custom value list, type in 1 and press plus. Now it's 1. Okay. So sheet 1 and sheet 2. And basically I have a text box, right? So this is just a sheet with the words that I want my button to be. And then I created an action. So you can go to worksheet or dashboard if you're in the dashboard. For now, I'll just show it as if it was for the worksheet. And I have two parameter actions. So select sheet swap, parameter 1. This is the Explore Models sheet, which is this one. I called it Explore Models. And my other one, well, let's just use this one for. So whenever do I want to select the button? Do I want to hover over the button, or do I want a menu? So menu would be I click the button, and then there's a little pop-up, which we call a tooltip, and then there'll be a button in that. I rarely use that. So we're just going to use select. We want to select the button. We don't want someone's mouse to run over the box and then the thing switches by mistake, right? Set current value, I put as 1, my primary sheet that I want to be as the default. Target parameter, I put as my parameter. And that's about it. So I did that a second time, but I did the opposite. So this one is my button, Explore Models TXT, which is Explore Models TXT. And dashboard, or sorry, worksheet, actions, select. My target parameter sheet swap. Explore Models is my default field that I'd like to swap. And set value to 2. So we've got our 1 and our 2. So when I click, basically a parameter action is when I click, it's going to automatically filter from a 1 to a 2. So when the filter is a 1, it's going to show me them. And when the filter's a 2, it's going to show me this one. And this one is hidden because 2 is being shown. So very confusing, I understand. If you've done it a bunch of times, you just do it like autopilot. Basically, the reason I did that is because I don't want, EO or a CMO to see the other chart, right? So I could have just easily put 2 charts next to each other. Too distracting, and it's for the wrong audience. This is more clean, and it's side. And then if I'm gonna, I can just get rid of it, right? Bring it back by Control Z. So that's the 5-minute run through. If you'd like me to send you some links to a written or YouTube video with explanations by people more talented than me for you. But yeah, any other questions that came up?
Not in the chat.
Okay.
I want to get into the code, but anyway, that's just me.
What was that? Can you say it again? The code. You
No,
want to get into the
I
code?
said I'm looking forward to the code, but that's good.
Oh, cool.
No, good explanation so far.
Yeah. Okay, so basically, you guys can still see the screen?
Yep, we're looking at GitHub.
Text on it. Okay, perfect. This is my GitHub, so you can just go to github.com/Colin McDuffie. That's my name. And basically, we're gonna look through some of this. So I've tried my best to write everything out. So if you forget everything I say today, you can read through it, and the instructions are clear and concise and explain everything. So this is the dashboard we built. We're going to create our dummy data, which is, where's my home page? I think it's back here. So basically, we have all these variables, right? And so the dummy data is going to produce something that looks like this, right? So index is our row number. We have our date. We have Google Desktop. I'm going to go through on the other one, which we have, but you can see all the data here. So what you can notice is there's different ranges of the values, right? So Google ROAS, return return on ad spend, how much revenue you generate for every dollar that is spent. That's obviously a very small number, 1, 2, 3, 4, 5, 6, right? And you've got other variables like how many dollars we spent on Facebook, 6,000, 7,000 per day. That is a bigger variable, right? So when you're doing models, sometimes that can be an issue and sometimes not. So there's something called standardization or normalization, which basically will convert all your values to like a 1 to 10 scale or a 1 to 100 scale. That way they're weighted more evenly. But in the case of this example and this model, it's not going to be an issue. But that's just something I always tend to look at. And then obviously the data types, right? In this case, everything's numeric, and then we have a date field. That is necessary for these kinds of models we're building in Python. So if you had something like a market, like market is Los Angeles, market is Beijing, etc., you're going to have to repeat the model several times for each market, and then do a union together with your results, right? So for this, we're not doing by market. We're not doing by whatever else you might want to do it by. Okay, so we've got Google desktop visits. That's how many people, that's how many people visited our website based on Google search. This is how many converted. So that's basically how many people purchased orders. Then we got mobile visits, mobile conversions, how much money we spent, and the total amount of revenue that Google produced, and the ROAS, which is revenue over spend. Got the same for Facebook. Got the same for direct. So direct would be if I went to Google or I went to my browser and I typed in, whatever IKEA.com, right? That's a direct visit. It didn't cost IKEA any money. It was a free visit. And so bounce rate is what I explained before, like the percentage of people that click off your site within a second. Session duration is how much time they spend on the site on average. Pages per session is how many pages they view for each visit they have. Conversion rate is that thing I showed earlier. Would be the slope of transactions and visits. So it's transactions. How many transactions do you get, or how many visits does it take to get one transaction, essentially? Total conversions, total orders, total revenue, total spend, total profit, total ROAS, right? So a lot of these, so the question is, we got 30 different variables. So remember that question I asked earlier, right? What is the least number of variables you need, right? So if I throw all this into Python and run a bunch of models, it might be expensive, maybe not important. Like maybe this variable has 0.1% impact on the output variable, right? So it's not critical, right? So there's no reason to spend money on running a model on 30 different columns in this situation. So we're going to use Python to tell us which ones to use. So all that data I showed you, everything today is completely made up. It's all fictitious. So, but before I jump into creating the dummy data, do I have any other questions so far?
No questions at all in the chat.
Okay, cool. So it's kind of weird. So I have create web traffic dummy data. When I open the Python file, it does this blinking thing, and when I try to download it, the button doesn't work. So what I did earlier today is I just created a text file. So here's the text file. You can paste this into Python, and it'll run. So I'm going to open it in Microsoft Word real quick. Give me 1 second. Got it. Sorry, let me share again. Share screen. Share screen. Okay. So I'm going to run through this super quick. And obviously, at the end of the document, I'll ask if there's any questions. So basically, we've got a couple things here. And if you're not using dummy data, if you're using your actual company's data, then you still want to know about this because you want to know like what variables are being produced, what sort of parameters and ranges we require. Like for example, in this situation, I wanted the start date of my data set to go from 2022, January 1st to 2024, December 31st, right? So for this model to work, we need a couple years of data. Excuse me. The channels, we got Google, Facebook, direct, devices, mobile, and desktop, right? So if you guys use Pinterest for advertising or TikTok or something else, feel free to just replace the word with whatever you want. Right? I should do TikTok. I don't know if that's an international thing or not. But we'll keep it at Google for now. Okay. So conversion value, that is the average revenue per order. Okay. In this case, I made up a number and I said $20. Every item we sell is $20. Okay, great. So this sort of stuff here, I basically have spend per visit, and I want the range to be between these two numbers, right? So np.random.uniform, it's basically saying generate a list of random values for this date range from 0.01 to 0.03, multiply that number by 10. Okay, so you can also just do it like this. Whatever, right? So spend per visit is how much advertising dollars we're spending for every visit we get on the site. So in this case, we're saying it costs 10 cents, right? So Facebook, we have, I made the value lower, and direct, obviously that's made up because direct doesn't cost any money. But let's pretend this was YouTube, right? You can say what you want the range to be. This visit to conversion ratio, mobile to desktop ratio, it's basically telling it that I want the how many orders I want. So for the first one, it's a conversion is orders and visit is visit to the site. So I want the visits to be around 20 times bigger than the number of conversions. I just made that up because I felt like it. Mobile to desktop ratio, I want one of them to be around 3 times more than the other. Okay, but you can play with these numbers, and I just made them up. So, and then you can check, run your file and see what you get, and if it's something that you think is good. Mean conversions, that's how many daily conversions on average I want to be the average. So we have different conversions. Where's conversions? We have different number of conversions, but I want the average to be a certain number. Okay. Desktop visits, okay, mobile visits. So yeah, there's a lot going on here. It's not important that we go through everything. It's already done. It's already written. So yeah. So if you guys have questions further about this, feel free to message me on LinkedIn or something like that, and I can go through more details, or you can punch it into ChatGPT or whatever else you want to use. But bottom line is you run this, you get a data set. Okay. Any questions on that stuff?
No questions at all so far.
Okay, cool. So now we're going to get into the beginner dummy web forecast model. this is, I've never used Python. I don't know what I'm doing. This guy, Colin, told me I can create dummy data. I did it. I pressed run. I got a worksheet, CSV on my computer. I don't know what to do with it. What should I do? Well, you go to this thing now. All right. So basically, this loads the CSV into your Python instance, and df.info lets you know what all your columns are. This is my data type. This is the names of the variables. So if there's any columns you don't want, so I know I don't want ROAS for Google in my model. Okay, great. Just type it in right here, and it'll drop it from your data set. So this is optional. These are the different libraries that are being imported. So in this case, I just did one model. So the advanced one has 3. I think 5 would be too many, 10 would be too many. So let's just do 1 and let's 1 and 3. So this one we're deciding we're going to use random forest. So that's been imported. And this, I'm making sure that my date field is a date. So sometimes when you have date fields, they might be a string or they might be, who knows, right? In this case, it's general, right? Sometimes they come out looking like this, and you gotta, right? So there's all different kinds of, and this might be like, it might be a text field, right? So just in case, we want to make sure it's a date. So take the date field, make sure it's a date. If there's any missing data, if there's any dates that are missing, we're gonna just put 0, right? So that's also optional, but features, these are the features I want to include. So I decided I'm going to run my model. Now you could type in all of them if you want, but I thought this would be a good way to start. And target is total revenue. I'm interested in how much revenue we're gonna make. That's the goal. If I wanted to determine what's our conversion rate going to be, I could write conversion rate. If I want to predict how many visits are we going to get, I can put in visits, right? If I want to predict the bounce rate, we can just type in bounce rate. But obviously, the revenue is the juicy stuff that sells better, right? If you advertise a Tableau session and says, run a model to predict the bounce rate, you're probably not going to get a lot of people sign up. But if you say, run a model to predict how much money we're going to make, people say, oh, that's good. I want to figure out how to do that. Okay. So that's what we're going to do for this one. But it's really up to you what you would like to predict. In the case of in-store, we sometimes use foot traffic, right, as that. So this is standard for model building. Test size is 0.2. You could do 0.3. So it's basically saying, okay, I have all my data from, remember we did 2022, 2023, and 2024. So I'm going to take 20% of that, or sorry, 80% of that, and train my model. So that's like saying you're going to read a book and then you're going to have a test. And the test is not going to be the exact same thing as the book. But based on what you learned from the book, you're going to answer the questions on the test, right? And so that's what this is. That's the logic here. That's why we literally call it machine learning. The machine is reading data and coming up with a prediction as to what it thinks the answer on the test might be, even though it's never seen the test before. So if there's anyone involved in random forest, so random forest is basically, my understanding is a decision tree that is averaged together many times over. So I put n estimators as 100. That basically means we're going to run the decision tree 100 times and see what we get. So that can get computationally heavy. You can do 10, you can do 1,000, whatever it is. Depending on your data and how long it takes to run, you may want to increase or decrease that. That may also impact the R squared. Any questions so far? No. Okay.
No questions.
Okay. So R squared, if you don't know, is basically saying what percentage of the revenue can be explained by this data. So 88% of the revenue can be explained by this amount of data, and 12% is explained by things outside of this list, right? In statistics, we're never going to be 100% sure of anything. So 0.88 is a tremendously good number, in my opinion. Anything 0.75 to 0.95 is really good, generally. So that determines if the model is good to go. So is the model good to go? Yes, it is. This is if, in case you want to visualize your model. So predicted total revenue, actual total revenue. As the actual total revenue increases, so does the predicted. This is a linear relationship. And obviously, there's dots that are not on, if you drew an invisible straight line, they're going to be not all touching the line, right? Unless your line was this, like super thick. So that's why there's not 100% certainty. But generally, the trend, it looks good. So thumbs up, we're going to keep going. The next thing is something that I created and think is really helpful for folks. And that is feature importance. So each of these is called a feature. And what I'd like to do is, again, you can run the model with every single feature. Okay. And it's going to tell you based on 0 to 100, or in this case, 0 to 1, it's a percentage. So these are percentages. How important is the variable, right? So if I said, in this case, Facebook mobile visits is the most important. So if I said, or if I was asked, hey, Colin, how much money are we going to make next week? I would say, well, how many variables, how much data can you give me? I'm only going to tell you the Facebook mobile visits. Okay, that sounds good. Or I'm only going to tell you one variable. And which one do you want? Okay, can you pull Facebook mobile visits? Sure, I can pull that. Great. That'll be my first choice. Now, if I get to choose 2, I'll choose these 2. If I get to choose 5, I'll get to choose these 5. What you can start to see is that these variables have around 1% or less impact on changing the revenue prediction. So what this is telling me is, for example, Facebook spend, the bar is very short. Facebook visits, it's very long. So what this is telling me is it doesn't matter how much you spend, right? Even total spend is the last one. If people aren't visiting the website, you're not going to make any revenue, right? Does that make that should make total sense, right? Um, you know, average session duration, not important. So what this tells me is if someone goes to the website 5 times, that's more important than if they went once and spent an hour, right? That's not common in real life, but again, this is all dummy data, so this is just what the data is showing. So what you can do is say, okay, I'm going to use these 4, and I'm going to pump it back into my model. So I'm going to erase, whatever, and just pump in these top 4. And I'm going to rerun the model and see if my R squared goes up. I bet it will, right? So that's a way that a method I designed that can help you to know out of your 30 variables, do we need all of them or do we not need all of them? Make sense? Cool. So this is the last page. So we got 8 minutes left. I will stick around a little bit longer in case there's questions. I have been talking for a long time, so I'll definitely think we'll be good to go at 8 o'clock, or that's Pacific time. I don't know what time zones you guys are in. So yes, so there's some really helpful information here. I know it's against presentation protocol to read blocks of text to your audience. So I'm gonna try not to do that. Some of this I've already gone over, which I said generally the R squared of 0.75 to 0.95 is an acceptable range. But one thing you'll want to do is look at the spread between the min and max of your final prediction values. So that's one thing I meant to go over on the Tableau that I forgot to go over, and I will do that now, which is how do you make the bars? Right? So we all know how to make a bar chart, right? I just drag in a field right here, go here, make a bar chart, boom, bar chart, right? That's a piece of cake. But in this situation, I don't want bars, right? I could have a bar for my low and a bar for my high. I just want a little bar, right? I don't want a whole bar. I want this white space down here. Much cleaner. So what I figured out is you can actually do a Gantt bar and oops, let me get rid of this. So there's my Gantt bar. And what I do is I bring in a size variable, which is basically the max minus the min prediction. So I told them I'm going to go over this in just a sec after we do the advanced. But this is a formula that says what prediction is my max, and then this one is what prediction is my min. And then I just take the difference between those two, and I drag that into the size. Boom! Now you got a Gantt that has a size component. That was something cool. I've never done it before this use case, but came up with that as an idea. Yeah, I meant to show you guys that earlier. So that's what this is going over. So you basically have to look at the spread, right? So you want your R squared to be good, but what if I made this bar chart and my bars were super far apart, right? I had a huge bar, went all the way down to here. Well, that's going to make the audience think that my model's not a good model. So I would want to omit that model or modify it, or do the standardization or normalization that I talked about, where you convert all these values 1 to 10 scale and then rerun it, whatever, right? So I want to engineer a way around improving the model's accuracy, right? The R squared is great, and you can pat yourself on the back if you have a good R squared. But at the end of the day, we want these bars to be as tight as possible, right? So that's what that is explaining. So one thing I thought of was the reason I used 3 models is because I thought, okay, so the audience isn't going to understand what a 3 max model is. It's not going to understand what a random forest is. It's not might not understand what 10 other models are that I try. But if I can say that I ran independently 3 different models written by 3 different Nobel laureates, completely different method, run in vacuums, and got same or similar or very, very close revenue predictions, then I feel really good about my revenue model, right? That's what I thought. So that's why I ran 3. So that's what that is explaining. Okay, if you run this model and you can't figure out how to get your R squared up, reach out to me. I'll try to help you if that's something you guys are struggling with. Okay, so I'm installing my libraries, importing my libraries. Before I go on, any questions so far?
No questions at all.
Okay, cool. I'm getting coarse in my throat. Thanks, guys. All right, so I'm just going to run through this really quick. So we're going to load our data from a CSV. Okay. We want our date to be a date. Okay, cool. Set the index. So that is basically saying, make sure you look at these in order, right? So Python, it doesn't always know that January 2nd comes after January 1st, but it does know that 2 comes after 1. right? So that's why I created this line right here, and then fill nulls with 0. So if there's ever missing data, go ahead and throw in a 0. The model may fail if there's nulls, right? So that's why I did that. Define the date range you want to use for your model. So I have 2022 to 2024 in my data set. But I was thinking, 2022, I think we had COVID going on. Maybe things are different. Maybe we were 99% mobile web orders, but that's an outlier because usually we're only 50% web orders, right? 50% in store. So I artificially just decided or arbitrarily decided, let's just use 2023 and 2024. So if there's any interest in shrinking your data set, feel free to use that. If you don't want to shrink your data set, you don't need to run that. If there's any variables that you want to drop, you can type them in here. You can drop them. So in this case, I don't want it to know the conversions, because if I tell it the conversions, like the number of orders, then it's very easy for it to predict the revenue. And guess what? I'm not going to know how many orders we're going to get next week because it's not next week yet. But I do know how much we're going to spend next week, right? So that's why things like spend are very common to use for, and some of these other efficiency metrics that e-commerce media buyers are constantly using and aware of, right? So this is what we want to predict, the feature that you want to predict, total revenue. If you want to predict something else, type in something else. Optional, just double check what's the min and max data of my data set, making sure that this worked, this part right here. So this is also important. This is, so if anyone's done data science models or machine learning models, basically a standard rule of thumb is a 70-30 or an 80-20 split. So 80% of your data is used to train, and 20% is used to test. Now, in the case of this, we're using sequential data, right? It's based on a date. So I don't want a random sample. I want the first 80% of the data set to be used for learning, and the second, or in the latter 20% to be what we're guessing revenue to be, right? So I said I want to define, instead of an 80-20 split random sample, I want to define September 1st as my split date, right? So any data before that, I want it to learn, and any data after that, I want it to predict up until this date. Make sense? Cool. This is just a standard thing that you're going to see in lots of machine learning models. So yeah, all this is just standard. Not going to go into the proofs for why this math works and what's going on here. Feel free to just run it. Again, we have our number of estimators for the random forest. You can increase or decrease that if your model is taking too long to run. XGBoost, this is all standard. You can, this is the learning rate, so like how fast do you want it to learn? That's my understanding of those numbers. And then we have the Cerimax. It's a good model for retailers with seasonality, right? So how do you know you have seasonality? You have lots of variability, lots of ups and downs going on. So you might have, like, if you're selling bathing suit, swimsuit, whatever, maybe in the summertime sales go up, and in the middle of winter sales go down, right? So that's considered seasonality. That repeats cyclically every year. I know we're running low on time. Give me 5 more minutes, then we'll be done. Okay. So I'm not going to go into this details of this. Feel free to throw this into ChatGPT or reach out to me if you need help. This is basically saying take all my results, all my models, put it all into one table, right? So I don't want all this data, right? I don't want all these variables. I just want date and my revenue prediction. So this is my output table. I also want to add columns for my R² value. And this is it. This is my my data set. Notice how there's no prediction for January 1st, 2023, because that was the learning period, right? But starting on this date, we have data. So that data set right here went into Tableau, and now we have a Tableau dashboard. So that is the explanation. Happy to stick around if anyone has any questions or needs some clarification.
So Philip's question, it just jumped off, I'll just bring it back, said, if you look at the conversion of purchase, does this model take into consideration returns or refunds as the inverse of conversion, or could it predict returns or refunds?
Good question. So we don't get a lot of returns in my job, in my company, which is good. And there's something where we would consider written sales versus delivered sales. So in the marketing department, we're really focusing on written sales. So how many sales were written? Now, the finance team or another department might be interested in delivered sales, right? The delta there being canceled orders, rejected shipment, damaged goods, etc. Right? So it's not just returns. There could be the product is broken, it fell off a truck or it fell off the boat in the middle of the ocean, right? So I don't care about any of that. I just want to know how many people ordered something. So that would be the short answer. Now, if you were interested in that and you were working outside of a marketing department, then you probably would subtract. You would just do net conversions, right? So you'd subtract the returns and the lost items from the ones that were purchased. So so yeah. And then what was the second half of the question again? Does the model repeat?
It was about, could it predict returns or refunds? So yes, you could just predict refunds rather than revenue.
Yeah, you just type exactly. So you would have to have historical data on what percentage of your orders are returned, right? And then if you had that information, you could use that as the output variable as opposed to revenue.
Yep.
Mm-hmm. I see a lot of questions. I see 38 messages. Should I scroll through?
There's a lot of chat. That's all the questions from within it. So.
Oh, gotcha. You've been reading. Yep. Okay.
There's like Adrian asking about the links and stuff like that. So yes, there's a whole heap of chatter there, but that's okay. I've been trying to pull the questions out of it as you go. I've got them all.
Gotcha.
That's fine. Awesome. Thanks for that. All Colin's details are on the screen. Obviously, they'll be in the recording, and you can look at those as well. And Adrian didn't confirm it, but I just hand typed your GitHub link into the chat, so I think everyone's got that as well. But again, you probably your name's similar to mine in a way that if you spell it right, you can find you.
Yeah.
You know how to spell it right and put all the right letters in the right place, and then it's easy to find.
That's right. Cool. So awesome. Yeah, I don't know who any of these people are. I'm sorry we didn't meet or whatever. But thanks for showing up. I appreciate it. Feel free to shoot me a message. I know, it's a small community and we all want to make friends and we all want to talk with one another and learn from one another. And I'm happy to participate in that at any time if you guys decide to reach out. I think you said that they're going to put a YouTube video, or you're putting a YouTube video. Okay.
Yep.
What would be the channel for that? What's the YouTube channel called?
Oh, I've got all those details in the slides, but we'll get to that in the end.
Oh, perfect. Yeah, go ahead. Yep, I'm all set. So
Q&A, we've done the Q&A as we go through. I think I'll unmute everyone at the end anyway, so we've got time to talk if anyone wants to say anything. But just the last little section of this is the fast five. So fast five questions for Colin. It's a really quick question, a really quick answer. Don't think about it. Just give the best answer that you can think of really quickly.
Sounds fun.
Sounds fun. And no one's seen these questions before, so there's no good or bad answer. It's just what you think. Are you ready?
Yes.
So what's your favorite Tableau Python library? Tableau Python library. I was sort of gearing it towards a presentation a different way. Maybe you don't use these.
I mean, so you can't. So my favorite Python library is Pandas because it's like the most like commonly used thing. If you've never used Python, then that would be a place to start. And the follow-up to that question would be, there is an integration, an API of Python in Tableau called TabPy. So definitely TabPy would be my favorite.
Yep, that's good. And you've sort of answered the second question, which is which Python library do you use most often in Tableau and why? Is that probably Pandas? Yep.
That is definitely Pandas. Yep.
Yep, that's cool. If you could add one feature to make Python integration in Tableau better, what would that be?
I love that question. So I would say it's not the Python language, in my experience, in the Tableau interface is not verbatim Jupyter Notebook, right? So I'd rather have a instance of Jupyter Notebook in Tableau as opposed to Tableau's sort of like calculated field sort of interface. That would make things really easy and helpful. I know I use Alteryx as well. They have a Jupyter Notebook embedded into their platform, which makes it super easy to copy, paste, etc. Yeah, that's
awesome.
That's probably my
answer. The Python implementation in Alteryx is really nice because it feels like a notebook as well, but in Tableau it's always a little bit different.
Yeah, and also there's a lot of process, like the reason I'm doing all this in Jupyter Notebooks is it's a lot of data, it's a lot of machine learning. So it's best to like run the model first and then visualize the data in Tableau, right? Yep. So at the end of the day, Tableau is data visualization. It's not necessarily made for big data crunching computations. Every time you click a filter, every time you click an action, if it has to rerun that Python code every single time, that would be tremendously slow, right? Yep. So sort of integrating Tableau with some sort of Python engine outside of Tableau would be tremendous, right? Right now, it's kind of, you have to do it all over here on this side of the room, and then after the data is done, shoot the CSV over to Tableau and display it. It's not necessarily, the model is not continuously running. You can imagine there's companies that want models to run all the time and never stop. And how do you visualize that in Tableau? That'd be a challenge. So
yeah, definitely. Awesome. Next question. When integrating Python and Tableau, do you feel more like an analyst, a data scientist, or a hacker?
Data scientist for sure.
Cool. That's what I thought you'd say.
Yeah.
And if someone told you they're scared to use Python and Tableau, what would you say to them?
You're right. It is scary. That's what I would say. You're not wrong. It takes a long time. It took me years to figure this stuff out. The good news is, I would say right now, especially like I only started using like AI like in this year, I would say. So AI is super helpful. It's the same stuff as Google or Stack Overflow or whatever, but I officially took all my Python books and sold them actually last week. So I was like, anything I need is on the internet, right? So It's very easy today. When I was in college 10 years ago, I needed books to understand what statistical test to use. I don't know, Chris, if you ever like had those tables with all the like z-scores and things like that, right?
Yep.
Yeah. So those days are over, right? You don't need z-score tables anymore, right? You just use this kind of stuff. So it's easier now than it's ever been. And so hopefully that motivates you as opposed to scaring you. So.
And I'd sort of, my little story on that is I've struggled for years with, going into ChatGPT and saying, oh, can I just get some code for this? And it will quite nicely give you the code, but it just doesn't work. And here a few weeks ago, I just, I almost just look at it for boilerplate code now, and I know the code won't work, but I'm going to ask ChatGPT for like a boilerplate to begin with. And I forget what the question was. I'm like, oh, can you give me some code to do this? And it wrote all this stuff. Oh, that's right. I was terraforming. I was saying, if I've got a CSV file full of projects, what's the script for pulling that CSV file and making all the projects in Tableau Cloud? And it gave me this code. And I went, oh, okay. And I pasted the code, and it ran perfectly the very first time. And it's the same as you. You say, I don't need to read as many books and do as much research anymore. It's getting to the point where if you can explain what you're doing properly, then the code is almost perfect. And that was the first time where it was like, perfect the very first time. That was impressive.
Right.
Getting better all the time.
Yeah, and a lot of the like Google BigQuery has Python Jupyter notebooks in it. And they have a Gemini embedded, so it can actually look through your data. So you can ask it questions like, hey, how much revenue did we make last week? And it'll find the data, it'll find the table, and it'll go, ChatGPT doesn't have any idea what your data is.
Yeah, exactly.
So I think Databricks has Genie now or something. So there's all different AI models that are native now to Python library notebook like software. So it's getting really advanced, and it's really exciting.
It's getting better all the time. Yeah.
Mm-hmm.
Awesome. Thank you for that. So the next TUG meeting is Scott Eaton talking about Dashboard Standards Simplified, which is a repeat of his TC25 talk. So on May the 13th or the 12th, wherever you live in the world. So in a few days' time from that, we'll see Scott on here as well. This recording, this TUG recording that we're doing now, and everything else that we do on Team DataFam TUG and for a lot of other TUGs around the world is all accessible on YouTube. So youtube.com/@teamdatafam. There's a Spotify podcast, there's an Apple podcast, or email me if you need any further details. But that's about it for today. Thank you, Colin, for attending. There's only a few people, so I'll make everyone a presenter so they can unmute and talk. And just ask any questions if you need to.
Cool, that sounds great. Yeah, I'll stick around a few minutes. I can't remember. Did we say 75 minutes was the target? I think we literally exactly, we nailed it. We did exactly what we thought. So I'm happy we weren't short or long on that. So.
And as I said, it's more what time do you need to do that as well. So if you need more time or less time, we can fit that in.
No, it felt like I covered everything I needed to or wanted to cover. So
that's good. And everyone's a presenter, so people can unmute and talk. Cassie was saying about a Google Colab. I missed the rest of that chat.
And Adrian, I think I've seen you before. Have you presented at TC? You look familiar.
Adrian's been a forums ambassador for years. He's a visionary.
I think that might be where I've seen him then. Yeah, that's right.
And this shows my bad Canadian geography. I think he's in Toronto, but I'm not sure.
Gotcha.
But he was saying before, when you were starting, he was saying it was 7. It was 10 o'clock for him. So he's like East Canada, not West Canada.
Oh, gotcha.
And he's probably still on mute because so he did a session at TC this year.
Awesome. Oh yeah, he's in Canada. That's great.
So anyone can unmute and talk if they want to, and no one's game to, which is always good. I don't know if that's good or bad.
I know it's always. I mean, I do virtual uh, sessions sometimes too, which are 3 or 4 hours,
Yep.
and it's really hard. It's like, at what point do I, you know, it's not like when you're a teacher walking around the classroom, you can like look over their shoulder and see what they're working on, right?
Yep.
Or you can look at them in the with your eyes and ask them a question, and they feel more inclined to respond. But if I do something where it's a group of people in a lecture hall and they're all like, and I'm like on this big like Wizard of Oz face, it's kind of like scary, you know?
Yeah.
So
I did the same thing. I did a lot of online training, and I was teaching, in person in Sydney the other day to a group of, I think it was 60 people in the room, and then probably another 20 people on Zoom as well. And I just went, oh, when I'm teaching, I just sort of, sit here and talk, and I've got both hands on the keyboard. And when I've got to hold a microphone so that everyone can hear what I say all day, it was interesting to say, can I teach and talk into a microphone all day long? And I've only got one hand left to do everything I was doing on the laptop. Like, okay, but it was cool. But yes, in-person training is just so much better than online.
That's right.
It's just COVID came along and killed it. So what do you do?
Yeah, the first ever Tableau user group I went to was like after COVID, and I think I was only one or two of the people that showed up in person, and there was like 30 virtual. I was like, you guys are all local. Come on over. Like, what are you guys doing? And slowly people began to show up. But obviously, in person has pros and cons. Virtual has pros and cons. So.
And that was my concept for this tug as well, is, if you're presenting, because I think you presented this locally to, was it the Seattle tug or something?
Orange County, California.
Orange, yep. And it was another presentation that happened here locally, and I just went, there's all these in-person presentations that have got all this awesome content, and you've got to be in the room to see it. Like, if you're not there in the room, you miss out on it as well, which is when I sort of started to think of this tug of saying, I can contact all these people. They've got a presentation because they presented it in person. We just need to, exactly what we did with you, find a time that suits you, that suits me, put it online, record it so that then goes on YouTube. People can be watching this thing in 6 months' time and contacting you saying, I've just watched your presentation, That's
sure,
exactly
that's right. That's true. Yeah, and my Tableau public is a little underwhelming. Every time I do a new sort of presentation, I put stuff up there, but I don't. I have hundreds and hundreds of dashboards with private data and private information for people, and I don't like to put them up. It's really never been a situation where I felt comfortable doing that. So. If you guys need or want more on Tableau Public, I guess I figured if people ask me to put more stuff up there, I'll do it. But so far, yeah, I've only got about 5 or 6 dashboards up, unfortunately.
That's good. And again, Tableau Public is what you want to make it. So if people want to do a lot of stuff there, that's great. I always say that mine's just a dumping ground of proving what Tableau can do, but it's not pretty at all. I don't show people my Tableau Public profile to show off because, what's my most recent workbook was probably a few years ago. We were joking about a solar eclipse. I know you can do a solar eclipse in Tableau, right? Because you can there's the sun, there's the moon, you can do that in Tableau. And everyone was saying it's not possible. So because it's not possible, then you go and make it happen to see if it can actually work that way or not.
Yeah, I remember when I was at the Tableau conference a couple years ago, and the Fleur-Lerge twins were doing a presentation, and I can't remember what it was they were showing, but they said it took them about 30 hours to figure out. And I was like, okay, so if it takes me 100, that's actually really fast, because like I'm still like learning and they're the best in the world. So, a lot of little things take a ton of time. I mean, the sheet swapper took me, I don't know, a whole weekend to like throw together. Right. And that's all just for doing stuff for no reason. And so, yeah, it takes a lot of time. I mean, I've been working on Tableau for a while now to get to this point where I'm able to do this kind of stuff.
And I made the mistake in online training one time. I was teaching Tableau, and one of the guys goes, because I said, I've been using Tableau for, I forget what it was at the time, more than 8 years. And he said, how long does it take you to learn Tableau well? And I said, I'm still learning after 8 years. And he just sort of took it the wrong way, and he's like, oh my God. And I said, no, sorry, don't misunderstand me. To learn Tableau easily, you can do that in about 3 or 4 months. I said, to learn Tableau at like this extreme level, I said, Tableau's coming out with new features every quarter for desktop, for server, for cloud, for prep. I said, you can't keep up with the new features. And he's like, oh, okay. And I said, back when I learned Tableau, there was no LODs. I've had to learn LODs along the way. Everything is done in map layers these days. There's all these new things all the time. That can you keep up with that or not? Maybe you can, maybe you can't. It's up to you. What do you use Tableau for? Because everyone uses it differently.
Yep. And I try not to reinvent the wheel. So if there's ever a task that I'm given, I mean, I've proudly said throughout my career that I've never had a task or an ask that on Tableau that I wasn't able to complete. I've got 100% success rate, but I try to just look for the internet. I mean, there's so many visionaries, there's so many YouTube channels and websites and Tableau Public, and I try to find, did someone else in the world do this thing that I'm trying to do? And if the answer is no, then that's fine. I'll work on it. It's rare, but most of the time there's something out there, and it's very easy to leverage others if you sit on your couch all day trying to learn Tableau and you don't you don't go to the conference, you don't watch YouTube, you don't go on Tableau Public, you're going to be very slow to becoming an expert. So yeah, it's kind of like it's like trying to use Python without libraries.
Yes.
I mean, the libraries are hundreds of rows of scripts shrunk down into one line for you, right? And
so that's what Philip just asked. For someone new to Tableau and Python, what are the 3 great resources to start? And I just said, a challenge to focus on and some data that you love looking at.
Definitely.
Like there's a lot more behind that as well, but it's just find something and start on it. Is that what is it? Jacob Rothemund. So Jacob Rothemund in Sydney, he just did the Formula 1 race animation, and I was working with him a little bit on that, but he did it a lot better than what I could. And just sort of went, there was a chat in WhatsApp going, can the Formula 1 races, and you see that automated thing that they do, I wonder if you can do that in Tableau. And again, it was a few ideas and playing with some data and I don't know how many hours he spent on it, but one weekend he goes, I'm going to do it this weekend, and posted on Monday, went, there you go, there's a Formula 1 race in Tableau with all the progress bars going the right way, and he had the tyres and the pit stops and the retirement and everything in there. It's just find something you like and find a way to do it in Tableau. And there's the new Slack community now and stuff like that to help with things. Is someone's going to help you. You've just got to reach out. There's people on Reddit and Discord all the time asking for questions, and it's like sometimes it's this tiny little thing that will help them because I've been using Tableau for over a decade. They might have been starting using Tableau last week. The same thing with sheet swapping. It's just ask, have a demo workbook. Someone's going to help you somewhere.
Definitely.
But anyway, again, we'll wrap it up this time. No one's unmuted. Everyone's just talking in the chat. So, so that's good. Thanks for your time, and we'll talk to you soon.
Okay. Yep. Talk to you later.
Thanks a lot, Colin.